In this video, we're asked to find the point that partitions directed line segment AB in a 2-to-1 ratio. Now there's a few words that are important here. First off, partitioning. Partitioning just means to split into different pieces, and the pieces are equally sized. A directed line segment is one in which the point matters, or the order of the points matter. So like if you think of AB as starting at point A and going to point B, that would be directed line segment AB. Now, we need to split this up into a 2-to-1 ratio. So what that means is two parts need to be closer to A and one part needs to be closer to B. That means, since it's a 2-to-1 ratio, that means there's 3 total parts. So we have to split this line segment AB into 3 equal parts. I'm going to do this to help us out here. This just shows in total how far it goes down and how far it goes over. And if you just count that, the total, it goes down 3 and over 6. That's good, but now we need to figure out for each part. So if there's 3 equal parts here, all we have to do to figure out how big each part is divide these two numbers by 3. So each part should go down 1 and go to the right 2. So let's start at point A. We go down 1, to the right 2. Make a little dividing line there. From that point, we're going to go down 1 over 2 again. Put another dividing line. And then from there, I go down 1 and I go over 2, and I'm at point B, which is exactly what we wanted. Now we have to find the point that splits it into a 2-to-1 ratio. So remember, we want 2 parts closer to A and 1 part closer to B. This is easy. We can see the parts right now. There's 1 part here, 1 part here, 1 part here. So if we're going 2 away from A, just count 1, 2 parts from A. Hopefully it's this point right here. And just to check, oh yay, look, it's 1 part away from B. So we have 2 on this side and 1 on that side. That means the answer is the coordinates of this point, which are 5, 0. So just to recap really quickly, the 2-to-1 ratio part is helpful because if you add those two up, you figure out how many parts to split up your line segment into. Then you have to figure out in total how far does your line segment move vertically and how far does it move horizontally. Once you know those numbers, you just divide by the number of parts, and that'll tell you where to split up your line segment. In this case, we split it up going down 1 over 2 each time. And once you find that, you have your line segment split up into however many parts the problem is telling you. You just find the one where it's the proper number of parts towards the proper number or the proper point. So in this case, we wanted 2 parts close to A and 1 part close to B. That point was at 5, 0.